Thank you very much. Thank you very much for this warm welcome. I really enjoy being here. Warm welcome from my side. I'm broadcasting here from beautiful Austria to people, as I saw in the chat, from all over Europe. And I'm looking forward to 3/4 of an hour about real-time serverless apps with Node.js, Azure Functions, and Azure SignalR. I promised you a talk with nearly no slides and lots of demos with an end-to-end demo, and this is exactly what I'm going to do. I will keep the introduction as short and crisp as possible, and then after, let's say, 5 minutes or so, we will immediately jump into Visual Studio Code and the Azure portal, and we will dive into the example and take a look what's going on behind the scenes and how we can implement the architecture that I'm going to introduce you in a second, how we can implement all that with TypeScript and JavaScript and Azure and things like that. Before we go into it, let me quickly introduce myself. My name is Rainer Stropek. As I was introduced, I'm a passionate developer. I love writing code every day. When I can write code is a great day. I do a lot of work with Microsoft technologies. I'm a Microsoft Azure MVP. I'm an MVP for developer technologies and a regional director. That does not mean that I'm on the payroll with Microsoft. Absolutely not. I have my own small consulting company, which is called Software Architects, and we help small, medium, and large companies. We have been doing that for over 10 years now, being successful in the cloud. We really focus very much on the Azure part of the cloud, not because Azure is the one and only best cloud, but we just have to focus. The day only has 24 hours, so Azure is our home ground, and this is why I'm talking about it. If you want to get in contact with me, the easiest thing, to be honest, is to go to this website here, reinerstropek.me. That's a kind of digital business card from myself online on the internet. And if you scroll down on the right-hand side, you see it here. You have a bunch of social media accounts, my YouTube channel, LinkedIn, and so on. If you would like to keep in touch, please go there, click on one of the icons, and I would love to keep in touch with you, answer any questions that come up after the conference, for instance. If you would like to get the code samples, here is the link. Maybe you can take out your phone and take a picture, or of course I will share the slides with Software and Support Media, the publishing company running this conference, and they will share the slides with you. But if you can't wait and you absolutely want to take a look at the code now, you can go to this URL. It's part of my GitHub samples repository. So I have opened it up here. Here you see it. Here you see the content of my talk, and as you can see, we will focus on the DevOps part, the backend part, the front-end part, and I also published the slides in this folder here. By the way, there is a trick that I always recognize that many people are not aware of that. Did you know that you can, here at github.com, add 1S here, press enter, and guess what? You will get my code directly here in a Visual Studio Code environment, directly here in your browser. And if you would like to follow along what I'm going to show you, you can easily switch to this view. You don't have to clone my repository because there's a lot going on in that repository. Just browse through the code with me, and maybe it's easier for you to follow along. So maybe this is an interesting tip for you, for those of you who weren't aware that this feature exists. Okay. Let's dive right into it, and this will be the last slide that I'm going to show you. In this slide, I did a bunch of animations to introduce you to the core problem that my talk is all about. You see, the classical way of working with web applications is kind of this one. You have a client, a front end, could be a single page app like here in Angular. In my example, it will be Angular, but use your imagination. It could be React, it could be Vue, it could be Svelte, it could be whatever you want. This client interacts with a web server through a web API, and this web API interacts with a bunch of backend, let's call them microservices, and of course with a bunch of databases, something like this. Now, the non-trivial part is this one. This stuff sometimes takes a while. Maybe I have to talk with a big, large SAP system in the backend. Maybe I have to talk with a legacy database system, which is rather slow. And that could lead to a situation where my API simply takes a while. Or maybe you have some number crunching going on, or you have to generate a dozens and dozens and dozens of pages long PDF, which takes quite a few of CPU power, and it simply takes a while. And the typical solution to that many applications I see out there in the wild use to solve this problem is to keep the HTTP request idle. For the entire time, it can take seconds, maybe even minutes. The problem? This doesn't work in the cloud. In the cloud, you typically have network components that will terminate your idle HTTP requests, and you will never get response from the server back. Additionally, the user experience is not very good because you cannot show the user a progress indicator or things like that. It's simply not a good solution keeping it idle. Another solution, I forgot something. It becomes even more complicated if the communication between your, let's say, backend for frontend and your backend servers is through asynchronous communication mechanisms like, for instance, Kafka or Service Bus or RabbitMQ or whatever you use in that context. If you do that, implementing the web APIs here in the backend for frontend is not a piece of cake because you always have to translate between HTTP and asynchronous requests and messages and wait for the incoming message, find the correct response and things. It's not a trivial thing. So many companies and many teams move towards polling, the good old polling. Of course, it's inefficient, but let me quickly show you why and recap what polling means. It means that the first request from your frontend to your backend for frontend returns immediately, but that means that the business transaction has not been finished when the HTTP response arrives at the client. You again have a complex backend here on the right-hand side, and the client continues to ask the server, are you ready? Are you ready? Do you have a response for me? Do you have a response for me? And of course, polling means that you keep the client busy, you keep the server busy, and the user experience, again, is not the greatest. So polling is a possibility, but not a good possibility. Wouldn't it be beautiful? Wouldn't it be beautiful if we could directly access the server from the server to the client? If we would have a duplex communication between server and client? And of course, you all know that, you are web professionals. There is a standard for that, and that is called WebSockets. And this is what I'm going to talk about. But I'm not just going to talk about WebSockets because it becomes particularly interesting when we talk about cloud, scalability, and async processing in the backend. And combine that with WebSocket. What do I mean with that? Think of the client, think of your API. The client initiates a business transaction, for instance, let's say an order, and the server will immediately respond with, for instance, an accepted response. It will not say, I'm done with the business transaction. It will just say, okay, I got your request. It seems okay, and I'm going to start working on that request now. And then a lot of magic happens. In the back end, we have messages flying around, things are waiting for a certain amount of time. Maybe we even have long-running processes where we have to involve humans who maybe accept or decline certain, let's say, credit lines or something like this. We have to talk to legacy systems. It maybe takes minutes or hours to process the order. And after a certain amount of time, when everything is done, we would like to push a message to the client and tell the client we are done. Now, building such a system in a proof of concept isn't very complicated. WebSockets isn't complicated, well supported in Angular. There are protocols like SignalR, which I will talk about in a second, that make it even simpler to use WebSockets. So where's the problem? The problem comes in when you want to scale this stuff. WebSocket has a state on the server. Therefore, scaling servers that are on the server side handling the WebSocket connection, is definitely not trivial. You have to have a server farm, the servers have to communicate between each other because maybe the user is now here on that server, but in 5 minutes the user is on a different server, and if you want to send back the asynchronous response, you have to find the correct server that the user is now connected to. A lot of backend communication that you have to implement. So scaling isn't trivial, number one. Number two, we don't want to keep all these servers alive because servers which are constantly active and alive cost a lot of money in the cloud. So therefore, what we want to do is we want to go for serverless computing because that is the most cost-efficient way of running APIs in the public cloud, especially if we are talking about asynchronous message processing and dealing with long-running business transactions. So what we essentially would like to have is we would like, as developers, focus on the client side, the user experience, do what we can do best with TypeScript and JavaScript, and in this case, Angular, build a great UI. We would like to focus on the message processing in an asynchronous event-driven way, and the entire duplex communication, WebSocket, SignalR, we don't want to bother with that. And this is what this talk is all about. We are going to take a look at an end-to-end sample where we have an Angular client, a fully serverless backend that scales automatically and still can actively talk to the Angular client without running a single SignalR or WebSocket server. We're going to use a serverless WebSocket SignalR service provided by Microsoft in Microsoft's Azure cloud, the so-called Azure SignalR service, and I'm going to show you how you can combine that with the serverless functions, which also work great in Azure, but also outside of Azure. You can run them in your on-prem Kubernetes system if you like. It's completely open source technology. And we will put these things together so that we as developers can really focus on building solutions and do not lose the duplex communication between the backend for frontend and the frontend. Now, before we go right into the code, I have to talk a little bit more about this SignalR stuff that you see here. I'm not talking about WebSockets here because I'm here at the iJS conference, so I guess everybody is at least a little bit familiar with WebSockets. But if you are not from the Microsoft universe, let's put it this way, then you might not know what SignalR is. SignalR started as a Microsoft proprietary technology way back years ago. It's a pretty old standard, but now SignalR really has evolved. SignalR is today a protocol, an open source protocol where you can find the protocol specification open on GitHub. You can find it here. And essentially it implements, you see it here, a protocol for RPC, remote procedure calls, especially between a JavaScript TypeScript client and a server written in, I don't know, ASP.NET Core, Node.js, Java, Go, whatever you want. SignalR is just enhancing the WebSocket protocol to make it really an RPC protocol. And the beautiful thing is it supports duplex communication. So you can send messages from the front end to the backend, from the backend to the front end, and you can even do async streaming in both directions if you want. I'm not going to go into that today because I only have 45 minutes, so it also cares for handshaking, finding out the correct protocol. Does the client and the server like to use JSON or a more efficient mechanism like message pack and so on? There is a handshaking mechanism going on. I already talked about the invocation types. And finally, it also does regular pings to detect unexpected disconnects, so you can gracefully handle the disconnecting of clients or the reconnecting of clients. This is essentially what SignalR is all about. This talk is not a deep dive into SignalR. It's enough if you remember, SignalR is an open protocol sitting on top of WebSockets. And if WebSockets wouldn't work on other technologies like long polling or server-side events, but this is out of scope of this talk, it's just an RPC protocol sitting on top of WebSockets, making it particularly simple to call a method from the server on the client in JavaScript and vice versa. And that's it. I promised you only a few minutes of introduction, rest of the talk, code, code, code. So let's stop PowerPoint here. I added more slides in this slide deck for your reference. So if you would like to take a look, you can definitely do that, but I will not talk about those slides. It's really just as a reference because I would like to show you the things in practice. Let's get started. What you see here is the first of 3 projects that I would like to introduce you to. This one cares for the DevOps part. It already says here on the left-hand side DevOps, and you can find it in this folder here. And it's essentially automatic creation of all the necessary Angular artifacts that you need to run an application like that. So what you can do, if you would like to replay what I'm going to show you in the next few minutes, you can take this folder, if you have an Azure subscription, and simply run this script. It will deploy everything you need into your specific Azure environment, and you immediately have everything you need. This concept is often referred to as IAC, or infrastructure as code. Yeah? And I really would like to encourage you to do IAC, to do infrastructure as code. I've seen many people clicking around in the Azure portal. That's fine. If you're just learning, if you're exploring, if you want to just read and take a look at how your Azure environment looks like. But if you want to build something serious, production grade software, always automate stuff. Use, like I do here, ARM templates, or bicep scripts in Azure, or Terraform, or PowerShell, or Bash scripts, whatever you do, but use infrastructure as code. With this, you can share what you have built with other teams, with other people. You can make code reviews, you can test these things, you can repeat these things, you can audit these things. If you just click around in the portal, nobody will ever know what you thought about when you clicked on a certain button in the Azure portal. Here with infrastructure as code, you have Git, you have a Git history, and it's just code, and you have really a nice system where you always know what's going on and who did what and why. So this is an example for infrastructure as code. And I would like to walk you through certain parts of this ARM template. If you're new to Azure, don't worry. You will understand the core principles from the context. So this is not just for Azure experts, absolutely not. I will walk you through the code, and it's not necessary in this talk that you understand every single line of code. That would not be possible. Too many technologies involved here. The first thing that I would like to draw your attention to is this one. This is serverless functions in Azure. It's a technology which is called Azure Functions. Functions are essentially pieces of code, technically speaking in our context here, Node.js functions, which are triggered automatically when a certain event happens. An event could be a timer, an event could be an HTTP request, an event could be an asynchronous message through an AMQP message broker, like Service Bus, or maybe something with a Kafka protocol, or maybe a RabbitMQ message, or whatever, something like this. So Azure Functions is event-driven computing where you write code and your code is triggered by can be triggered by a wide array of different events inside your cloud environment. In my scenario, I will use 3 important triggers: HTTP trigger, message bus trigger, which is just an asynchronous message bus, AMQP compatible, and SignalR messages coming from the client. This is Azure Functions. I will not talk about the detailed configuration here. If you want to take a look, you see here are several settings that you can go deeper in if you want. If you want to really understand what's going on, take a look at my sample. It works from end to end. Just copy it, run it. It will work. And this should be just for your reference. We are talking about the architecture here. So let's just accept that we have Azure Functions running our Node.js code. By the way, it can be Windows or Linux, it can be inside container or outside container, it's whatever you want. Now the next stuff here is this service here, SignalR. And this Azure SignalR here is the real hero in our story. Because what Azure SignalR does, it's implementing the server farm terminating your WebSocket connections. So what you can do is you can start an Azure SignalR instance. And this Azure SignalR instance will then be out in the cloud, has its own DNS record, and will sit there and wait for connections from your clients. And you can connect with 1 client, 10 clients, 100 clients, thousands, tens of thousands of clients. Let Azure SignalR worry about scaling this server farm. We don't have to care about that. The only thing that we care about is the pricing. You can buy SignalR based on nodes, and 1 node supports a certain amount of connections. So you simply have to find out how many connections can I anticipate, and then you buy the appropriate number of nodes. And of course, this number of nodes can change over time, and you pay for the number of nodes that you have reserved at a certain point in time. But you do not need to worry about VMs, about networks, about load balancers, about failovering, all these things. This is completely done by the Azure SignalR service. You don't even have to understand the SignalR protocol. That's out of scope. That's not for you as a developer. You just deploy this thing, and it's really simple. That's everything you see here. That's the whole code snippet here, and that will give you this Azure SignalR server. With Node.js, we're going to use this thing in the so-called serverless mode. That means that I tell Azure, hey, implement WebSockets and SignalR without me understanding this protocol. I will not be sitting in the background and getting forwarded all the messages. No, that will not happen. What I will do, I will talk the REST protocol, HTTP in the backend. So I talk HTTP post if I would like to send something to a client. Or I will receive an HTTP post, just like a webhook, if a client sends me something through WebSocket SignalR. I don't have to talk SignalR. So it's a kind of protocol translator doing the duplex communications, and I do what I can do best. REST APIs and webhooks. That's simple, and that is exactly what I want to have. A simple thing in the background that lets me focus on what I really want to implement. Last but not least, the last element here in the DevOps part is the service bus. This is the communication with the backend systems. So if I go here in my slides again, just for a second, this one is the SignalR part. This one is the service bus. I'm talking to my backend microservices. I'm talking to the maybe legacy systems in the background, or maybe huge ERP systems like SAP or things like that. This is the service bus that lets me asynchronously communicate with my backend systems. Okay? These are the 3 things. In order to save a little bit of time, I already ran these scripts, and as you can see it here, this is how it looks like in the Azure portal. If you're not familiar with the Azure portal, that's the Azure portal, and here you see where our serverless functions run. Here you see the service bus, which we use to asynchronously communicate with our backend systems, and here you see the Azure SignalR. That's the front-end WebSocket SignalR endpoint ready to receive connections from my single-page app, in my case, Angular. And now we are going to take a look at the code which runs here and the code which runs on the web server, and the web server will run somewhere here in a static storage account. I just need static website hosting, nothing more. Good. So, ARM template, infrastructure as code, deploy all the resources, and remember 3 things: Azure functions for running my serverless backend for frontend, service bus for backend communication asynchronously, AMQP standard conform, and SignalR for doing the WebSocket SignalR communication with the single page app. Before I move on, I will take a sip of coffee and take a look at the chat window. Maybe there are already questions. No questions yet? Good, so we can continue. Let me switch to my second window here, and that will be the backend. I already started the debugger in this backend, and before we go right into the SignalR part, let me quickly, in 1 or 2 minutes, give you a very, very brief whirlwind introduction into Azure Functions, how that works from the viewpoint of a Node.js TypeScript developer. This is just TypeScript, just Node.js, nothing special, 100% open source, and you can run this code definitely also in your on-prem Kubernetes cluster if you want. I am running it here in an emulator in the local function tools, but we can also deploy that stuff in Kubernetes in the cloud or in Azure Functions. Now to get going, I created a very, very simple function here. You see, I called it ping and it returns pong. And this is how you implement a serverless function in Azure. All you need to do is you write a single Node.js function and then you accompany that code using a JSON configuration file. And here you see the JSON configuration file. You specify the trigger, which trigger should lead to calling this method here on the left-hand side. And in our case, for this simple ping pong, it's an HTTP trigger. And you specify so-called bindings. And in this case, it's an output binding. You see that one? And that means that we return an HTTP response. And in my case, I'm just responding with a little bit of JSON. That's it. If you want to try that, we simply set a breakpoint here. Let me set a breakpoint. Go into my request here and call the ping endpoint. You see it here? Let's call it and voila. This is what I wanted to show you. Here you have the TypeScript code breakpoint inside of our ping method. And we can take a look at the context. You see all this stuff. I will not go into the details. I will just keep it running. And you see, we respond with pong. Everything is fine. So from 10,000 meters height, what is an Azure function, a serverless function? It's just a Node.js function, or if you use a different languages, it could be a Python function, it could be a PowerShell script, it could be a C# function, it could be a Java function, whatever language you use. But here we are at the iJS conference, so of course I'm using TypeScript or JavaScript if you want, you can choose to implement those functions. Now let's go a little bit deeper and take a look at the order processing. I built here a very simple order processing. And let's take a look at the order processing functionality here. The first function that I implemented as a showcase here is this function here, receive incoming order. This is a typical backend for frontend function. It will receive the order. Here you see I'm taking the order from the request body. It's extremely simplified and partly naive code. I want to focus on the architectural aspect and not writing the best possible production Node.js code. So please bear with me here. This method receives the order from the single page app client, but it doesn't process this order. That is the important thing. It only does very simple sanity checks. Does it look decent? Does it look okay? And if it looks okay, we just return accepted HTTP response code here. We just say, hey client, I got it. You want to have an order. I've not started and by far not finished completely processing this order, but I accepted it. And this is the important thing that I'm so hard fighting for, this one. Because this receive incoming order is a way more interesting function than the ping function before. Let's take a look at the configuration file here. And I want to draw your attention. Sorry, that was the wrong one here. The order, that is the right one. I would like to draw your attention particularly on these two bindings. This is the trigger, of course. We have in this trigger here, let me zoom in so you can follow along a little bit better. This trigger here receives the HTTP request from the single page app client. It accepts a post request and triggers my Node.js function, exactly the function that you have seen before. But now comes the interesting part. We have an out binding for HTTP, which is just responsible for returning the accepted status code. But we have a second output. See that one? And this is connected to our service bus. The service bus is the message broker which deals with the communication with the backend system, with SAP, with your large-scale ERP system, maybe with external service providers, maybe even informing a human being that some kind of review is necessary for the order. Asynchronous long-running processing is triggered by a persistent messaging mechanism. The message has not been completely processed. The service bus is just triggering it. So for this demo, I also implemented, or let's say I kind of implemented, the backend, the powerful backend. Of course, this will be typically a separate backend microservice, maybe written in a different language by a different team, maybe even in a different part of your organization. But for this simple example, I put the same code here in this example. But use your imagination. This process order here is typically not living in the same service as my backend for frontend. This is the big backend. Now, this big backend receives the order coming through the service bus. It is automatically triggered by the service bus and does the heavy lifting. You see here, this is the heavy lifting, process incoming order. It writes to a huge database or whatever it does. In my case, it's just waiting for 2.5 seconds to simulate a little bit more complex processing going on. But again, use your imagination. This is the heavy lifting, what's really going on. And it can take minutes or hours. I don't care really. And now again comes the interesting part. Because here we have another binding. What we can do, if we take a look at the process order here, see this references the process order function here, it is triggered by a service bus. So the processing of the order is triggered by a persistent messaging in service bus. But the output in this case is now writing to SignalR. You get the idea? My Azure function, as the developer of an Azure function, I don't have to care about SignalR at all. All I need to return from my function is a little bit of JavaScript object that Azure then takes and sends to Azure SignalR, to the serverless SignalR WebSocket service. This SignalR service then translates this technically HTTP request into a WebSocket message and sends it out through WebSockets to the Angular client, so that the Angular client can asynchronously inform the end user sitting out there, hey, your process, your order has been completed, it has been processed. And it can be minutes or hours. The user can close the browser, log in an hour later, and if it happens that the order will finish then, he will still receive the message because we are not waiting for a response. We don't do polling. We don't do idle messaging. We don't keep a WebSocket connection manually up to date. Everything is done with SignalR. So in this case, we are sending a message through SignalR. I can show you that one here. This SignalR message is configured in the config settings of my Azure function. So here you see a connection string pointing to my Azure environment. By the way, it doesn't make sense if you copy that one. The credentials will be gone after my talk, so I will delete it. It's just a playground environment here. But this is the Azure SignalR connection string where we talk with Azure SignalR and send things out. You know what? Let's give that a try, and once we saw that it worked, we'll take a little bit more detailed look at how the authorization really works. So let's do the following. Let's go into order processing and set a breakpoint here at the beginning of our receive incoming order function. This is triggered by our Angular client, and I will show you the Angular client in a second. Now this message here should be triggered when the service bus contains a message. This is the backend, okay? Here in my third window in the front end, I have an Angular application. This is a typical Angular application. It's newest Angular. I refreshed my code for this very presentation, so everything is current. And if I go here to the app component, you will see that if I click on send order, we just do a regular HTTP post. You see it here? This is the HTTP post. But the response will not come in through an HTTP post. I wrote a little service. Here you see the service. And here, this one is the interesting line, because this is the connection on event handling coming from the SignalR connection. This is a so-called hub connection. This comes from the SignalR API, which is nice implemented in TypeScript, so it's not difficult to implement. It's just a few lines of code. And here, what I do is I take this incoming SignalR message and pipe it into an RxJS subject so that my entire Angular application can respond to it and maybe print a nice notification on the screen. This is what this application does. Let's see if it works. So let's open my app here. I already opened it here. This is my Angular app. I already loaded it. Let's clean the console here. Let's clean the network here. And the first thing that I have to do is I log in. We will talk about logging in later on. This is not real OpenID and OAuth. I just created a dummy JWT token synchronously signed with not very secret. In real life, you would of course use, I don't know, Auth0 or Azure Active Directory or Okta or Identity Server or whatever you use. Here, I'm just simulating it. I'm now logged in as John Doe. And now I click on send order. Send order sends an HTTP request. Here you see the HTTP request to our backend, and the backend already hit the Azure function breakpoint. So now I'm in a serverless function which was triggered by an HTTP request, event-driven computing. Now I will let this thing run, and we should see on the Angular side the accepted response code, and after a few moments we should go into the process order. But this connection from here to here this one is only loosely coupled, because we are not directly calling process order, but we are putting a message into service bus, and the message will trigger the next serverless function in a chain of serverless functions doing the processing. And afterwards, this one should then send the message through SignalR and WebSocket back to the client without us speaking SignalR. So let's continue with the debugger. You see, we immediately came into the process order. If we go here and we take a look at the order post, see that one? We got back the accepted response. Accepted means it was sent but not processed. Let's continue with that one. Let's run it. And at the end, we should go here, and after 2.5 seconds, we will end up here in a subscription for our server pushed event. This is the SignalR message we received from the server through the SignalR protocol, which went into RxJS subject, and the subject triggered this code. And here I'm just outputting something on the screen to prove the point that it really arrived here. Let me run this, and you see order appeared. Let me show the whole process again, but this time with a little bit less disturbance by the debugger. So here I will just open up a second browser window. So now I'm going to go to localhost 4200 and again log in as John Doe. So now we have, imagine, two devices. One could be your tablet, one could be your desktop computer. And now John Doe again sends an order. Sends order, HTTP, message broker, and here we have the processing. Let me load both. I did something wrong here because I removed something. Let me try it again. Send order, HTTP request, and processing comes back. You see? This is what I wanted to show. Both browser windows received the order processed message because this is the push message coming from the server through SignalR to all connected Angular clients. And everything without me caring at all about WebSockets or SignalR. let me show you, let me prove that this really works in the background. I will reload the page again, log in again. And if you take a very close look, you will find here in the communication area that my client now talks to WebSockets to my application. But how can it talk WebSocket with my application if I'm not implementing WebSocket? Well, if I click here, we will see that the response of this one is not directly talking WebSocket with this stuff, but if we take a look at the negotiate, that's the protocol going on behind the scenes, we will see that my Node.js application, without me doing anything, redirects the Angular client to Azure SignalR and gives back an access token that the Angular client can then use to go to Azure SignalR and say, hey, Azure SignalR, I would like to talk to you, and here is proof with this access token. Here is the proof that I am allowed to talk to you, and you please deliver my messages to this serverless function and the messages from the serverless function back to me. So we have a three-way communication here. The client talks to my Node.js serverless function. The serverless function redirects the client back to the WebSocket implementation by Azure SignalR and shows and it displays an access token with which the client can prove that it has the allowance of the application to talk SignalR to the serverless service. And then the backend communication happens with the REST API. Now, how does broadcasting work? This is the last aspect that I would like to show you, and then I'm through with my demo and we have a quick recap of what I showed you. The important thing, I summarized that here in the requests, is the negotiation protocol. This one, you see it here. This is happening behind the scenes, and you can find that code in my Angular app. I guess you understand what an HTTP request is, so I spare you the details of how this is done in Angular. It's just an HTTP post. This message here, negotiate, is sent to our Node.js application. And with this negotiate request, we send on the one hand side an access token. This is the access token that I showed you before. In practice, it would come from, I don't know, Azure Active Directory or Okta or Auth0. Now here it's just demo token. And we tell SignalR what our name is. So we can set properties like a user ID or a group name or something like this. And now comes the important thought. When our serverless function in the background would like to target the message to a specific user or a specific group of users, it doesn't need to send a broadcast. It can use this SignalR user ID to send the response to a dedicated user. If we take a look at the order processing, you will see that here, when we send the SignalR message, I add the user ID. And with that, it's the complex communication going on inside of Azure SignalR to find the correct node where the user is connected to. It could be tens of thousands of users connected. It finds the correct server on which the user is connected and uses exactly that WebSocket connection to send one message to exactly that user. Or if the user has multiple devices, of course, multiple messages are sent because multiple connections with the same user ID are absolutely no problem. So if I show you that, if I click on that one, you will see exactly what I told you before. My Node.js app says, okay, thank you, John Doe. You are okay. Please take this access token. By the way, I didn't have to generate that. That is generated by Azure Functions automatically. Use this this access token, present it here at this URL, and then you can talk WebSocket with this service because this is an emissary of mine. It talks WebSockets and it can send you push notifications, although that I, as the Node.js application, am just capable of talking REST API. This is what this architecture is all about, and this is what I wanted you to show. Granted, It was a whirlwind tour through these services. But I hope that you got an idea why I say that if you are okay with working with Azure Functions and Azure SignalR, that this is really a kind of dream team for scenarios where you have asynchronous event processing in the background, where you have a single page app web client with Angular, React, Vue, Svelte, whatever, and you would like to have a backend for frontend where you as the developer, you do not need to focus on implementing a highly scalable WebSocket server farm, but you just talk HTTP and REST API and let Azure Serverless SignalR do the heavy lifting for you and enable you to do exactly that one here. Push notifications out to the client. I hope you got some inspiration from this topic. And I would like, for those of you who think that this is now interesting, I would recommend taking a look at the details of the code here in this GitHub URL. Let me take a last sip of coffee, take a look at the chat and see whether we have any questions that I can quickly answer before we have to close the session, because the time is already over. Time flies. Do we have any questions? I'm taking a look at the chat window here in Swapcard. This is the URL of the sample. I only had 45 minutes, so there is a lot to discover in this source code, and now you have the source code and you can take a look. Thank you. Thank you. You liked the talk. I'm glad to hear that. Yeah, I think we can close it for now because I don't have any open questions. Thank you very much for joining me. Please remember, link yourself up with any social media platform that you typically use. I'm glad to answer any questions. And one little advertisement at the end, I have a second talk today where I give a brief introduction into the Rust programming language, showing you how you can combine Rust and WebAssembly with your JavaScript project. So if you are interested in Rust or curious what this Rust thing is all about that everybody's speaking about, take a look at my second talk today in the afternoon. I'm very much looking forward to it. For now, thank you for visiting my session. Thank you for being my guest, and I hope you learned something interesting and valuable from this session. Goodbye. Thank you.